Um, Hello, dear students. Welcome once more. This particular lesson is the fourth part of limits, which we had. The fourth part of chapter 7 limits. So we have really looked at the different aspects. Now let's look at continuity. This video is a very short video. Make sure you subscribe to this video and watch it to the end. We started an introduction of this video in the previous lesson, which was chapter 7C. And here in 7D, we just introduced some other elements to spice up the lesson. So a function is said to be continuous at the point x equals a if either the limit of f of x as x tends to a is equal to f of a, and this limit should not be equal to infinity. That is, the limit is defined, or the limit from the left is equal to the limit from the right. The limit from below is equal to the limit from above. And this limit should not be equal to infinity. That is, the limit should be defined. Here, the two-sided limit should be the same and equal to f of a. So we can use any of these definitions depending on the situation in which we find ourselves or the question that has been asked. And let us take some examples. Show that the function below is continuous at x equals 2. So that's the function. So this function is considered at x equals 2 if the limit from below is equal to the limit from above. So the limit as x tends to 2 from below, we use the first function as we saw in the previous lesson, should be equal to 2 plus 3, which is equal to 5. And the limit from above should be the second function. So we are going to use 3 times 2, which is 6, minus 1, which is 5. You can start the left-hand side limit equals to the right-hand side limit, right? Which is equal to 5. And it is defined. Therefore, g is continuous at x equals 2. So this function is continuous at x equals 2 because the both-sided limits are defined and they are equal, right? If there's something you don't understand, please you can watch this video over again and make sure you subscribe, as we are putting some rules. And very soon, those who have not subscribed to the channel will not be able to watch videos or continue to watch unless they subscribe. Please don't forget to share these videos and leave your comments too. Find the value of b for which f is continuous at x equals b, where b is greater than 0. We want to find the value of b for which f is continuous at x equals b, and b is a strictly positive number. So we look for the limit as x tends to b from below. That will be equal to the limit as x tends to b from above. So this will give us, that is b squared to be equal to 2 minus b. When we solve this quadratic by factorization, we will have b to be equal to 2 or b equal to minus 1. But we have been told in the equation that b should be a strictly positive number. Therefore, b should be equal to 2. A value of b here is equal to 2. Otherwise, b could have two values, either 2 or minus 1, but the equation says b should be positive. So we are taking 2 as the answer. Find the value of the constant k for which f is continuous at x equals 1. So at x equals 1, you want to see the limit from above should be equal to the limit from below, right? Because it says it's continuous at that point. So here we're going to have the absolute value of 1 should be equal to 2k into 1. That gives us 2k minus 1, and k is equal to 1. Find the values of k and t if these functions are continuous at 2 and 4 respectively. If you look at the previous lesson, this same question, we answered it, and these are the results that we had. So you look at this result, you see that we had k equals 1 and t equals minus 8. So you see that this chapter is an extension of 7c. Please watch 7c again and you come back to this chapter. So these are the values of k and t respectively if this function is continuous at the points 2 and 4 respectively. Okay. Find the value of k in this function for which the function is continuous at x equals 3 and the limit is 2. The limit at x tends to 3 of f of x. is equal to 2. That's what we have been told, right? And how do we get this limit? So that gives us k into 3 over that should be equal to 2. From there, 3k minus 1 should be equal to 2, since its denominator here is 1. And k will be equal to 1. These questions are very sweet. So easy. As they always say, the teacher's example is very, very easy, and the one that the teacher gives is difficult. Don't bother. Whatever the teacher solves, the easy one. Then the one that they give is the difficult one. If he solves the most difficult one, that most difficult one becomes very easy. All right, this question shows that g of x equals that is continuous at x equals 2. So to show that this is continuous, you can look for the limit as x tends to 2 from below and limit as x tends to 2 from above. Or we can just look for g of 2 and show that is equal to a number. And just look for g of 2, right? G of 2 is equal to 0. Or you can look for the limit as x tends to 2 from below and above. All the answers will all be 0. And we conclude that therefore this function is continuous as x equals 2. So if g of 2 is equal to a number that is defined, then it's continuous at that point. Otherwise, if it is infinity, then it is not continuous at that point. All right, guys, thank you so much. In 7D and in 7E, we are looking at L'Hopital's rule, the sandwich theorem, indeterminate forms, and all of that. This chapter is a very powerful chapter, especially if you're doing industrial, that is technical, or you're doing further maths. Make sure you watch this chapter, okay? This chapter is very, very important. All right, make sure you subscribe, because very soon those who have not subscribed will not be able to really have access to some of our videos, except those who have subscribed. Please subscribe, leave your comments and notifications, and you can comment on what you have said. Know that every Sunday we broadcast what we have studied during the week. We answer questions on that chapter. We do tutorials every Sunday at 2 p.m. 2 p.m. GMT plus 1. So for this week, we are looking at limits, and next week we'll be looking at differentiation. We have classes online for advanced level every Friday, Saturdays, Sundays, and Mondays. You can visit our blog www.gcmathspanelblogspot.com to have all the information that is required. Thank you. Stay tuned. Don't forget to subscribe, and bye-bye.